Welcome to this presentation, my second one at this PHP conference. My name is Rainer Stropik. I am from Austria, from a small software company which is called Software Architects. We develop standard software in the area of time tracking ourselves, and the topic that I'm going to talk in the next 45 minutes or so, OData, is in my professional life very, very, very important. We bet the farm on OData. We implemented in the last, I would say, 6 to 9 months, an entire custom OData implementation for our own product, and we really think that the world is going to go into that direction. So this topic means a lot to me, and I'm really glad that I'm here and have the possibility to talk with you about this new standard, why it's there, why it's important, and how it's different to custom REST services that you might have built already. Who has already come in touch with OData in the past? Who knows a bit about this standard? Okay, only one. Okay, perfect. Because this is what this talk is all about. It's about learning what OData is. So, excuse me, sir, if you are an OData professional, you might get some tips. Okay, you're not, so you just have heard from it, right? Okay. Okay. So, last few people are joining us. Just to make sure, are there people in the room who don't understand German? Okay, then we'll stick to English. Perfect. That's perfectly fine for me. I hope you understand my English. I'm not a native speaker. I'm doing my very best so that we can understand each other. If I can't find a word, or if you don't understand what I'm saying, or if you think it doesn't make sense what I'm saying, please tell me. I'll try to somehow translate it differently. Okay, let's first... warning, at the beginning of this talk, I'm not going to show you any slides. We're doing demo-heavy session. We're only doing demos. We are going to create OData feeds. We are going to consume OData feeds in various different tools. We are going to look behind the scenes using tools like Fiddler and so on. So please don't expect any kind of slides or something like this. I hope that's okay for you. So before we take a closer look at OData, I want to ask you the question, or I want to ask the question in general, why OData? Why is it important to have this OData standard? I mean, in the web service world, the world has agreed on REST, right? I think in the Microsoft world, the old SOAP-based model, I don't know if you know SOAP web services, is rather dead. I mean, Microsoft says it's finished or completed. You know what I mean? In German, I would say, es ist fertig. Yeah. So that means it's stable, it's there, it's going to stay there, you can use it, it will work fine. However, if you create new web services, you might be on a better position if you use REST-based services with formats like JSON and things like that. So we have REST. So why another standard? Is this web services, SOAP web services v2? Is this going to go away like SOAP 2? Well, let's take a look. Imagine you have a non-trivial application, a non-trivial ERP application, and you want to have a web API for this application. Well, you probably start with a web service. You could call it get customers, and you will deliver back a list of all customers. Then people will come to you and say, you know what, I want to have this get customers, but I want to have another request that's called get customers ordered by country. And then you are going to implement get customer by ID, by customer number, by first name, by last name. And you will end up having dozens, if not hundreds, of different web services. And then it goes on. You do the same for product, you do the same for order, and so on. You're going to have rather complex and a lot of web services. Only for querying. You will have the same for insert, the same for update, like store customer and things like that. And one advantage of OData is that it takes the idea of SQL, of a query language, to the web. Let's start with this idea. Just to remind you, If I take Microsoft SQL Server Management Studio, anyone in the room who hasn't seen or worked with SQL Server at all? Okay, you probably use something like Oracle or DB2 or something like this? Yeah? MySQL, it's fine. It's a relational database. Most in the room know SQL Server. If you don't know it, well, this is the IDE of Microsoft SQL Server. And if I take a SQL Server that is installed on my local machine, I click Connect, and yeah, I see a list of databases. Looks good. Well, that works fine if the SQL Server is in my local area network. Does anyone know the protocol that is used here? The protocol that a client uses to access SQL Server? No, ODBC is the API, but not the protocol. The protocol is called TDS, Tabular Data Stream. It's rather old. It has been created decades ago. It's well documented, and there is not only one client for it. This protocol is the workhorse of SQL Server for decades. So what's wrong with it? Well, it turns out that it works perfectly based on reliable network connections. So if you have the SQL Server on your local machine, if you have it connected via a local area network that is rather stable and fast, everything is fine. But imagine a world where you want to access a database that is not in your local area network, that is in a cloud data center, for instance. Let's try this. I love the cloud. We run our entire infrastructure in the Microsoft Azure cloud, and in this case, I created a small database here. I called it IPC 2014_DB. And this database runs, it's a database cluster consisting of 3 nodes, and there is a backup cluster in Amsterdam. This one is in Dublin. And I want to access this database using Management Studio. Well, let's try that. Connect database engine. Let's select a server. It happens that I know which server that is. Click on it. And you see, here I have my databases. Here I have my database. I can take a look at the tables. And if I want, I can run a query. And I can say select star from IPC 2014.events and hit F5, and I get the result. It happens that this table is empty. So what we now did, we accessed using Management Studio a database that is running near Dublin in a data center, and we used the wireless network of the Deutsche Telekom, and our bits and bytes traveled a long way to Ireland and back again here to Berlin. It works. It is SSL secured, so it is secure, no problem. But the problem is that this connection breaks as soon as the network connection breaks. And the internet isn't reliable. The network connection that I have here from Berlin to Dublin is long. It goes across a large way of internet service providers, and the errors or mistakes are the standard. So the connection is not reliable, and therefore this TDS protocol, the old way of running SQL statements, isn't good in a world where the database server is on the other end of the world, in a completely entirely different data center. Maybe you don't even own the database server. For instance, if you're a client of our own software which runs in the Dublin data center, it's called Time Cockpit, and you want to access your data in our database, we are not going to allow you to access your database directly because of security reasons. So we need something else. We need a new protocol. We need a TDS vNext that allows us the flexibility of something like select, insert, update, delete, transactions, where, group by, projections, all the things that we love from databases, but on a standard that has been built for the web, that has been built based on REST, HTTP GET, PUT, POST, DELETE, patch, and all the verbs that we know. You get the idea? Okay, this is why I said OData is the SQL for the web. It's a new protocol that is completely platform agnostic. It uses HTTP, it uses JSON, it uses XML. So there is absolutely no tying to the underlying platform that you use. Do you want to build a client for an iPhone? It works. Do you want to build a client based on Android? No problem. Do you want to build a client based on, I don't know, Windows, Mac OS, Linux? As long as the client can talk HTTP and understand JSON, the client is able to speak with our database immediately. So we don't need the complex protocol of TDS. That's the idea, the basic idea of OData. Okay? This OData thing is really a standard. The OData protocol, we can take a look at the documentation here. Here you see the documentation. The documentation, let me quickly go to OData v4, that's the current standard. And here you see, let's zoom in a bit, Oasis standard. I think since a month or two, something like this, the OData standard has been standardized by Oasis. So it's no longer a project initiated by Microsoft, owned by Microsoft, and somehow IP protected by Microsoft. No, it's a platform agnostic standard that now the entire industry can hopefully agree on. And this standard is getting more and more and more important. All new Microsoft APIs, web-based APIs that come out are based on OData. Office 365, the new Office 365 APIs, all of them are OData. Azure Active Directory, OData. Table storage, OData. Mobile services, OData. All these APIs are based on this OData standards. But not only Microsoft. Check out Amazon and search for SAP and OData. You will see that SAP and the SAP development tools, they rely heavily on this OData standard. So with OData you can access, read and write, depending on your permission, your SAP system. SharePoint, for instance. Do you want to get data out of a SharePoint list? What do you think? Which protocol is SharePoint using? OData. So what I want to say here is that this is not something esoteric that will come in 10 years or so. OData is there. And the big ones are relying heavily on this new standard. So let's check out what this OData can do for us. And the first thing that I want to show you is a read-only OData provider running in the cloud. It's a great way of playing with OData and learning OData. And this provider is called, if you know the Northwind, if you know the sample databases of SQL Server, you probably know the Northwind database. The Northwind database is a very simple database with only a few tables, things like customers and employees and orders and so on. And what I did here, I will zoom in a bit, is I used a plain vanilla web browser and I activated my OData service with the URI. And the OData service, and that's the first big difference to classical plain REST calls. The OData service is capable of giving me metadata. It shows me which tables are accessible for me. In this case, I access this feed anonymously, so there is no user password. Someone has placed this OData feed read-only for anonymous use in the internet, just to get used to it, just to play with it. Of course, you can limit the tables or entities, how it's called here. You can limit it based on user password. You can use OAuth to protect OData. You can use basic authentication. You can use a JavaScript web token or things like that, a JWT token, whatever you want to do. It works anonymously and it works authenticated. In our case, it's read-only and therefore it's open. And this is the first very important takeaway. OData comes with metadata out of the box. It's the same as if I work in this database, classical SQL world, I could say select star from information schema.tables. If I run it, I get a list of tables in my database. And this is the same in OData. You know what metadata makes so important? Metadata enables people to write generic clients. Someone can write a generic report generator that works on any OData feed. If you write the generic report generator, for instance, it immediately works for SAP, it works for Microsoft Cloud, for SharePoint, for our system, Time Cockpit. You want to see that? I can show you. I copy the URI and I take a tool that probably most of you know, Excel. I use a menu item here, external data, other sources, OData data feed. This works beginning in OData in Excel 2010, so it's already quite old. I copy the URI. I don't need any passwords here. Click on continue. And what this thing does, it gets to this OData feed and takes a list of tables, you see what I mean? And allows me to select the table that I'm interested in. That's the power of metadata. Excel does not know about the Northwind database or this OData service. Metadata enables it to query for what's available. If you write classical REST services and you want to build a generic client, it's very hard. You have to read the documentation to know which requests are possible. You have to read, as a human, you have to read the documentation, understand it, and hard code the names of the URIs or things like that. OData gives you metadata. But metadata in OData goes much further. What we can do is we can ask for advanced metadata by using the $metadata parameter here. I'm going to fire this query. And what we now get is not only the name of the table, it's called category here, but we also get a list of all properties, so fields. We get the data types, entity data model is EDM. The data types, we get information if it's nullable. We see if that's a primary key. We see so-called annotations. So the OData model is not fixed. If you have additional metadata that you want to publish, you can annotate the model. The generic clients will probably not care about these annotations, but your client might understand this annotation and behave differently. And of course, we can take a look. You see customer demographics, and here we see our customer table. The primary key is the customer ID. You see that? It's a string, it's not nullable, it's Unicode, and so on. You get the idea? So what Excel in our case can do, we can say, hey, give me a list of customers. Continue. Finish this wizard here. Yep. Hit OK. And that's it. We have a list of all our customers from this Northwind database here in Excel. Generic client. You want to see a different generic client? Who knows LinkPad? No one? One guy here knows LinkPad. LinkPad is a tool where you can write C# or VB and use it to query some kind of data sources. You can, on the left-hand side, you can add connections, and it supports, for instance, things like a link to SQL, so SQL Server, Entity Framework, there are drivers for MySQL too, and so on, but it also supports, here you see, OData. And what I've done is I have added here my Northwind service, and in this case, I see a list of querying for metadata tables. Now let's create a query. Let's create a query based on this service. And in this case, I'm not using a browser, but I'm using C# to query OData. From C in customers, select C. Hit run. And the system now goes to the internet, translates my query here into an HTTP GET request, gets the customer data, and presents the customer data in a nice little grid. This thing works with SAP, it works with Azure, it works with SharePoint, it works with any OData feed that you like. Okay? So, important takeaway on this point, metadata. Metadata is key, and if you want to know the details, then take a look at the OData documentation, You can take a look at the latest version 4.0, and there is a new language which is called Common Schema Definition Language, CSDL, and I can click on it, and here you see it's an OASIS standard. It's published in this case in February, and if I scroll down, you see all the different things, how this metadata works, and you can build your own, if you want, your own OData provider out from scratch. Of course, there are libraries. I will show you how we create a new OData feed in a second, but it is a standard. It's already there. Questions concerning metadata? Nope.
What's the representation of the data? What kind of, is it just only XML or it's
You will see that in a second. You will see that in a second. We are going to take a look at the data in a second. The metadata, you saw the metadata here. The metadata language is XML. But this is not the data itself. It's the metadata. Okay? We are going to talk about data in a second. Any other questions?
Why is it more reliable
Then what?
than the normal protocol?
Then the TDS. Okay, great question. Great question. Why is it more reliable? If you use, for instance, TDS with SQL Server, then an IP-based connection is established, and if something happens in this connection, the entire connection is broken. You have to reconnect. OData relies on REST, which relies on HTTP. That means it's not a connection-based protocol, it's a package-based protocol. So whenever you want to do something with a database, you send a new, we say, stateless request to the server, and you get something back. If then something bad happens, and for a few milliseconds the connection breaks, we don't care if we don't send the package during that time frame, and that's rather common, because you take a query and then you do something with the data for seconds, maybe minutes, maybe hours. So it's not connection based anymore, it's package based. And the second thing is, if you work for larger companies, try to connect to a SQL server that's outside of your firewall. You are probably going to be blocked, because port 1433, which is the standard port that, for instance, Microsoft SQL Server uses, is in most cases blocked, because firewalls can't inspect the traffic. This stuff here is based on HTTP and HTTPS, the standard protocol. So it works across proxies, it works across routers, and it works across firewalls. So this is the answer to your question.
Also, if you have more than one application, still not have permanent open channels.
Right.
Will not
Absolutely correct.
resources.
Yeah, it's if you have a server, this server can handle much more connections, concurrent connections, because it doesn't have a lot of connections open. The connection is open as long as the request takes. And if you are deep into, for instance, IIS, Microsoft's Internet Information Server, you know that there are so-called asynchronous IIS applications. You can, in ASP.NET, you can use async for implementing such web services, and that means that the request is not even blocked, or the connection is not even blocked while the database server is working. So it's really only getting into and getting out. Okay, let's go on and move from metadata to data. Let's take a look at a list of my customers. Customers. Enter. That's it. That's the representation of select star from customers. Quite simple. And the data that we get back, here you see all the data. Maybe you know the sample data. Do you know Alfred's Futterkiste? Somebody might know it. If you work with SQL Server for a long time, you really know this demo database. You see lots of customers, and you ask the question, what is the representation of data? And one option that you have is XML. But that's not a must. What we can do, if we don't use the browser anymore, I can use a web debugger, Fiddler. And we can do the same request here. Execute, and we will get back, here we have it, again, let's take a look at the raw data, you see, XML. The XML data, if we take a look, then we're going to see that the content length is approximately 24 kilobytes. So this is the length of the request. What we can do, if we have more control over the web request, we can say accept application/JSON, and when we send this request, we will get back the data in, you see, JSON format. So the OData protocol supports XML, for instance, for C++ or C# or Java clients, and it supports JSON for JavaScript, Node.js, in general JavaScript-based clients. And the advantage is here. See the difference? 5 kilobytes for the same data. This is why today most OData feeds focus on JSON and not on XML. But you have the choice. Okay? Excel, for instance, uses XML and not JSON. Get the idea? Well, that's nice, but how many of you write applications that only consist of select star? Well, probably not a lot. So we want, if we say we have SQL for the web, we want to have some kind of filtering, grouping, projecting, and things like that. And here we have the query language of OData. Let's go to the composer here, zoom in a bit, and say we don't want to have all the customers, but we only want to have the Alfred's Futterkiste customer. It happens to have the customer ID alfkey. And this works in OData like the following. You say question mark for parameters, and then you have quite a lot of keywords. They all begin with a $sign. In this case, we say $filter equals to, and then we can filter very similar to what you probably know from SQL. We can say customer ID equals, unfortunately in Fiddler I have to encode it here, %20 stands for blank. So don't get worried here. I will copy that to a browser and you will see you can write a blank there too, but Fiddler wants to have it. Equals ALFKI. Enter. Oops, sorry. Zoom out. Execute it. Take a look at the request and you see, what did I get back? Alfred's Futterkiste. Exactly one row. You know what happens here in the background? The URI, the query language which comes in the URI, is translated on the server side into some kind of query tree. We call it syntax tree. And this syntax tree is then translated into SQL, and the querying, the filtering, is not done in the application server. It really goes down to the database. So the database is really using a select star from customers where customer ID equals alfkey. So it's using, for instance, things like indexes. It's using grouping on the servers, aggregating on the server, and all this stuff. So we really have our own query language, but it is not SQL anymore. In fact, it is this URI-based query language. Do you want to know what this URI-based query language can do for you? Well, again, I refer to the documentation. You see, the URI conventions, can take a look. And I will not go into the details. I have so much more to tell you, but just that you see, I'll zoom in a little bit. You see filter, you can do equal, not equal, greater than, and so on. You can calculate results here. You can use string functions. You can use mathematical functions. You can expand. Expand is the same as a join. So you can immediately join other tables and return a joined table in a single request. You can project by using the select clause. I'm only interested in these two result columns, not all of them. You can use top and skip for paging. So you can say, give me only the customers starting with customer 100 and the next 10. Imagine a browser, a website where you want to page through the results. You can use server-side paging with this $top and $skip. You can count the result, you can format the result, and many, many more things. On a meta level, what do I want to tell you here? We have a new query language here. It's really a query language, but it's not the good old friend SQL. It's a query language that has been adopted to the needs of the web by putting these queries into the URI. Okay? If we go back, I don't know, 20, 30 years, when HTTP was invented, then the idea of a URI is a universal resource identifier. And if you take a look at the query here, we identify a resource. You see that? The resource is our customers table or whatever it is. And the URI identifies the resource that we want to query. So this works perfectly with the original idea of HTTP. Get the idea? Yep, question?
What about the writing operations?
Mhm.
What about the creation of functional
Yeah.
procedures?
Thank you very much.
Or update this stuff?
Yep, thank you very much. We'll do that in the next part. Any questions concerning the filtering language? If you write applications that target OData, you're probably going to write a lot of query applications. You want to get data out of SharePoint, you want to get data out of SAP, you want to get data out of Azure. So the query language is a really important part, but we are going to implement our custom OData service in a second, and then we'll do insert, update, delete, whatever you want to see. You have another question here.
As example, you're saying that this is some kind of new SQL language, right?
Oh, not SQL, a query language.
Query language, let's say. So what is example? I'm using Oracle.
Yep.
I'm using MySQL.
Yep.
And then I'm using my, as example, Microsoft SQL.
Yep.
So it means how it will, let's say, interact this query language with
Yep.
custom, let's say,
Again,
functions.
I ask you for a few more minutes of patience. You are going to see that in a second. Okay? Here is another question.
How complicated is it to restrict the list of possible filters to environments want to allow?
It depends on the server-side. You know what? Let's go to the next example. I think you want to see more, okay? You have enough from this Northwind database. You want to create your own OData provider. And it happens for me that I am a .NET developer. So I have to use .NET. I wrote that in the abstract, so please don't be angry with me. It's the only thing what I can use for writing applications. Yep, one more question.
If you want to change the database or an Oracle or something,
Yep.
so this will stay untouched. The syntax will be the same for the other database.
That's correct. That's correct. The query language and the entire OData standard is not tied to any kind of database. It's like SQL. Well, you know that SQL in its basic form is quite standardized. But if you want to go to the last bit of performance, for instance, you might need to use some database vendor specific extensions. And that's the same with OData. OData supports so-called functions. And a function is the same as, for instance, a stored procedure. If you call an OData function, you call it with a name, you give it a view parameter, and in the backend, you can do whatever you want to do. So the default way, things like simple where clauses, projections, and so on, they will probably work without any change across all different database vendors. But if you want to go to the last bit of detail, you might need to implement functions, and there you might to fall back to some kind of, I don't know, ODBC, ADO.NET, whatever you use protocol, and write the SQL statement yourself and translate the query yourself into a kind of query language, into SQL, for instance. Okay, so let's create an OData server. Here I'm using Web API, that's fine. I get a sample application. It's really very large and we don't care about the details. This is not an ASP.NET training. The only thing that's important, and I think even if you haven't created any .NET application ever, let's call this, I don't know, attendee. I'm creating a class, a simple class, and I'm doing a property here, attendee ID, and it's integer, and we're doing another property, string, and that's the name, and property, again, I do my age sample. For instance, just, that's it. That's our data structure. And I want to save this stuff in a database, and in .NET, for instance, I'm using a tool which is called Entity Framework. Anyone heard of Entity Framework before? It's an object relational mapper for .NET applications. And Entity Framework is the basis for data access in .NET. You can use any other thing in your programming language, but in .NET, it's Entity Framework. And it happens that Microsoft invested a lot of time and money to make Entity Framework work perfectly fine with OData. As soon as you have an Entity Framework data model that is completely database agnostic, again, Entity Framework can work with Oracle, can work with MySQL, can work with SQL Server, can work with Access, can work with ODBC, wherever you want to work. You can even write an Entity Framework, just a class like I've shown it, that can on the fly, at runtime, switch the database vendors. It works for Oracle, maybe in 1 second, and the next second it works with SQL Server. Entity Framework supports that. But I'm going to use an OData controller with Entity Framework, and the only thing that I have to do is I have to tell the system that I want an OData provider for attendees. In this case, I'm doing a very simple sample. I only have 45 minutes, only one table, attendee context, and that's fine, and hit OK. And now I'm going to show you the super complex code. Oh, sorry. I had to build the solution first. Sorry. Now we can take a look at it. That's it. And select the attendees and add a new data context here. That's C# specific, but I'm going to show you the code in a second. Hit OK. Come on, here we are. That's the entire code. It says, get attendees, give me an OData endpoint to query all my attendees. It says, give me an OData endpoint that allows me to update an attendee based on its key. That's all you need to know here. The post, insert an attendee, you see, just 3 lines of code. The patch, update the attendee, but do not update all columns, but only selected columns. And finally, delete an attendee based on its key. I made the attendee ID integer, and that's why the key is integer here. That's all the code that we need to run this sample. Just a few more things to set up. I'm going to show you that. We have to tell the system which URI we want to use, and that's it. We tell the system that we want to enable querying the attendees table in the URI OData. So if I run this and I say /attendee, sorry, it will not work, but we need the OData here. This OData corresponds to this OData, this OData here. Hit enter, I will see, and give it a second, empty result. This is already backed by a database. So this did already do a query to my local SQL server. That is what Visual Studio does out of the box. It takes the local SQL server. So now let's do an insert. I promised you are going to see an insert here. Well, let's do that. Here we have the URI. Oops, sorry. We have the URI. I copy it into Fitter. I change from get to post. I tell the system that I'm going to use JSON. And here in the body, I have to write the JSON. Of course, typically you don't write the JSON by hand, but you create some kind of HTML client or JavaScript client or C# client or PHP client or whatever you want to do. In our case, I'm going to show you the details here. We are going to implement attendee2 with the name, I don't know, Max Muster, and the age, 15. Note, I'm using the post here, execute, and you see, we got back HTTP 201, and that's for the HTTP experts in the room, created. If I go back to the browser, hit refresh, we just did an insert in the database via HTTP and OData. You want to delete it again? No problem. Delete /1 We don't have a body because we want to delete something. Execute it. Refresh it. Oops. Oh, sorry. No, attendee 1. I think I have to write it something like this. And there it is. Delete via OData. So with post, put, patch, delete, and things like that, you can write to the underlying database. Let me show you some examples that are out there in the wild, because this is just a sample database. Who uses that in reality? For instance, Windows Azure. If you run an Active Directory with Office 365, just because I'm curious, who uses Office 365? Exchange in the cloud, SharePoint in the cloud? Nobody. Okay, then this demo will not impress you very much. Imagine you run your Exchange server in the cloud. If you run your Exchange server in the cloud, and I think currently Microsoft has approximately, 60 million users, something like this, so this is not a small implementation. If you use Office 365, you have all your user data in the cloud in a system that is called Azure Active Directory. And for instance, I can log in into our own Exchange server in the cloud. I have to use a different credential here. Please bear with me. Come on. I will kill Fiddler. So, nope, this is not what I want to do. Login.microsoftonline.com, different account. Yep, that's the right one. And, yep, nope. That's the right password. That sounds good. And now let's get back to the Graph Explorer. Sign in. Yeah, and we are. You see, software-architects.at. And if we want to query our Active Directory in the cloud, we will immediately see the list of tables. You see that? Do you want to see a list of our users? No problem. Users, run it. Here we are. You see a list of all users. Should we look for me, for instance? Question mark $filter equals to, what do we have? Given name equals Rainer. That's my first name. Get it? And here we are. You see only one user, and that's me, Rainer Stropek. See that? So we can now query Active Directory using OData. You can access your Exchange server mailbox with the latest version of Exchange using OData. You can send an email by inserting an email record in the table messages. Exchange server will accept that request, will not insert it in a database, but it will send the email. So many companies, they only simulate the existence of a database. They just use the protocol OData without having a relational database in the backend at all. For instance, in our own case, in our own company, Time Cockpit, that's the case. If you subscribe to Time Cockpit and you log in with your user and a password and use the OData feed, it looks for you as if you would directly access the database, but in fact you're not. We implemented the standard ourselves, and we only simulate the existence. We translate the queries ourselves. It depends on how far you want to go. Okay? Same works for SAP, same works for SharePoint and things like that. So I think this is a rather powerful thing, what it can do. And let me show you at the end a nice little tool that might bring it all together. It's a tool from a UK company. It's only a small tool. It's for power users, for instance. And let's take a look at our Northwind sample again. Here we have it. I can use here a URI and again say $metadata. And what this tool does, I think it's a very nice tool. It, for instance, gives me a graphical UI of the data model. I can say, you know what, I want to see only the customer table. And you see, very similar to a database structure, you can take a look at the data model, and it's only based on OData. And it also contains a nice little query builder where we can say, you know what, give me a list of all our customers where the company name, no, here, the let's take the custom ID, equals ALFKI, hit on search, and if everything goes right, here is Alfred's Futterkiste. This is a generic OData client with a powerful query builder just relying on OData. It works for Active Directory, for SharePoint, for SAP, for Time Cockpit. It could work for your own application because OData is so generic. OData has been implemented now, for instance, in reporting services, Microsoft Reporting Service, a powerful report generator. OData has been implemented in ETL, extraction, transformation, load tools for building data warehouses. SQL Server Integration Services knows OData. OData is the heart of Power BI, where you can build impressive reports with maps, for instance, Power View, where you can visualize Europe and put your geographical data on a map, for instance. All this stuff works based on OData. Okay? So if you want to bring it together, OData allows us to do similar things that we do today with SQL, but the protocol has been built for the web. It is platform agnostic. It is a supplier, a provider independent standard, an Oasis standard, and it's easy to implement. In the .NET world, in the JavaScript world, if you work only in PHP, please use Google Bing or your favorite search engine and look whether the community has already done something in the area of OData and PHP. Unfortunately, I'm not a PHP guy, so I can't answer you questions to this topic. I hope that everyone got an idea what this OData is. If it's not the right thing for you, well, then you know now that you don't have to spend time taking a look at OData. But I think it could be relevant for one or two of you, maybe in the future, if you want to build your own provider or if you just want to consume providers like SharePoint, SAP, Azure, or whatever you have. I think this was the last talk of this conference. Is this right? I want to thank you very much for coming, visiting my session. Please fill out the evaluation forms. It's really, really important for us because we spent time preparing, so we want to know if you liked it. And if you have any further questions, please ask them. I only have approximately 5 minutes because my taxi is already waiting. I'm going to fly home today in the evening. But I wish you a very nice evening here in Berlin. Safe trip home. Thank you very much for coming.